Suppose you are going to see this lecture in the morning time. At that time, for that it is good morning. When you are seeing the lecture at the evening time, it is good evening, and in the night it is good night. Welcome to this lecture. In this lecture we are going to discuss again a very important topic in the chapter redox reaction. In the previous two lectures we have discussed about the very important and basic things. Number one, we have discussed that is what is oxidation process and what is reduction process. In the second lecture we have interrelate with the transfer of electrons with this oxidation and the reduction process. And in this lecture we will going to discuss again a very important thing, that is the oxidation numbers. So heading of this today's lecture is oxidation number. First, we want to understand how this concept came. In the reaction, that is the ionic reaction. Suppose this is a ionic reaction. Thus, the most common ionic reaction, we will say that when sodium is reacted with the chlorine gas, it will going to produce the NaCl. That is the very simple and very popular ionic reaction. In this reaction, you can easily able to understand the sodium is going to lose the electrons, and this lost electron has been accepted by the chlorine gas, and in that process there is a formation of a bond, that is electrovalent bond, and electron transfer is very much clear, very much evident in this reaction. But what about this reaction? When we combine hydrogen with oxygen, it will going to produce the H2O liquid. At that time, suppose this is balance. At that time, what we will say? That's not what we will say. At that time, we cannot. It is not, electron transfer is not evident. So how do we call this species? What about the oxidation and reduction of this species? Because we already understand the oxidation means the release of the electron. Reduction means the acceptance of that electron. But here you can observe there is no transfer, complete transfer of the electrons. Electron, we can say, basically is shifting because it is a covalent compound, and we know the covalent compound, the covalent bond, there is a sharing of the electron pairs. There is no transfer of the electron pairs. So how do we call its substance is oxidized or reduced? So for that, to track the electron transfer in the reaction of the covalent compound, this concept of oxidation numbers come. This concept has been developed. It is sometimes also called the oxidation state. This is sometimes also called oxidation state. And this is basically developed for the reaction involved in the covalent compound. Because in the covalent compound, we have to assume for bookkeeping that the electrons has been completely transferred to the more electronegative element. So in this case, what we will say, this oxidation number is 0, this oxidation number is 0. Here we will say this oxidation is number -2 and this is +1. How do you say? Now by assuming that there is a complete transfer of the electrons to the electronegative element. So how do we define the oxidation number or oxidation state of an element. This is basically oxidation state. Oxidation number basically defines the state of the oxidation state of the atoms of the element when they are covalently bonded or they are electrovalently bonded at that time, and we are assuming that the electrons involved and the covalent bonding has been totally shifted to the more electronegative element, and at that time we will call on the basis of the separate rules we will say about the oxidation number. So how do we define more practically? Let us understand. It can be defined as the charge developed so we can say what is the oxidation number or oxidation state. It can be defined as the charge developed or charge present by the atom of the element in its ionic state or assumed to present while the atom combined. Assumed to present in that case of the covalent bonding, because in the covalent bonding there is no shifting of the electron pairs, but we assume that electron has been transferred to the more electronegative element, and at that time we will call this is a oxidation number or oxidation state. It is not possible to memorize the electronegativity, because oxidation number is based on the electronegativity. For ionic compound it is not so necessary because the electron transfer is evident, but for the covalent compound that you have to always remember in mind the electronegativity difference, which elements having the higher electronegativity. But it is not always possible to memorize that. For that there is a certain rules to determine the oxidation number or oxidation state. And what are those rules? Let us understand. Rules for defining the oxidation number. First rule, that is the oxidation number of element oxidation number of atom of the element, so rightly atom of element in free state, or we can say this is the uncombined state. Uncombined state is 0. So with these things, that is O2 is in the elemental form, N2 is in elemental form, or any atoms, sodium, magnesium, potassium, all will have the 0 oxidation number, and we have to put a 0 in that point of this bracket. So oxidation number of the element in free state or uncombined state is 0. Second rule, that is the oxidation number of monoatomic ion, ions are its charge present. Are its charge present in the monoatomic ions? As for example, suppose this is sodium plus. Its oxidation number we will say +1. Calcium +2. Its oxidation number we will say +2. Then NO2 minus ions, oxidation number we will say -1. Sorry, this is not a monoatomic. So we will say, suppose chlorine minus ion. Chlorine minus ion, this will be the -1. So we understand two rules. This is very simple rules. The third rule, oxidation number of hydrogen is always in the combined state. Hydrogen in the combined state, that is the +1 always. But for metal hydride, suppose NH or CaH2, at that time this will have the minus. So hydrogen having always +1, but for the metal hydride it will be -1. Third number, oxidation number of alkali metal or alkaline earth metal is +1 and +2, and it is always a fixed one. Fifth number, oxidation number of oxygen is always -2, but there is an exception, like for peroxide H2O2, this will be having the -1, right? For superoxide, suppose KO2, it will having the -1/2, right? For O2F2, it will having the +1. For OF2, it will having the +2. So oxygen has lot of exception, but on an average we will see totally overall oxidation number of oxygen is -2, and in these cases it will different. Okay, that oxidation number of halides, mean metal with a compound with a metal, it is -1. But oxygen number of halide can be changes, except fluorine, that is chlorine, bromine, iodine, all will have different oxidation number, that we will understand later on. 7 point, the oxidation number of metals and non-metals. Suppose the compound has been prepared with the metals and non-metal, then oxidation number of metal has been positive, and non-metal non-metal is negative. Okay. 8 number point, the oxidation, that suppose there is a two elements in the compound and one element is electropositive and other is electronegative. At that time, the oxidation number of electropositive element will be positive and electronegative element will be negative, right? 9 number points, oxidation number of the sum of, we can say sum of oxidation number, sum of oxidation number of atoms, neutral atoms of neutral compound is 0. 10 number points, the sum of oxidation number of atoms of ion shall be the charge of that ions. So this is basically 10th rules that we have to remember, and very simple rule. You will, if you go through 1 or 2 times or 3 times, you can easily able to memorize it. Now what we will do some exercise. How, for a practical example, how do we able to assign the oxidation number to any compounds or to any ions? Okay. This is a complex compound and you have to say oxidation number of Fe. Oxidation number of Fe. For that, what we have to do, this is a neutral compound because it do not have any charge. And you have to know at the time when you are going to solve this type of problem, so you have to know that one atom you have to assign, you have to find out the oxidation number of one atom. Suppose here it is given ferrous, Fe, iron. So at that time you should know the oxidation number of these other atoms. So here we already discussed that metals and non-metal do not have a fixed oxidation number. That is, the metals it is +1 and the alkaline earth metal it will +2. So in this case, potassium as the +1 oxidation number, so 1, and that is, it is having a 4 into 1, we have to multiply with the number of the atoms. Then X is your oxidation number of Fe, and Cn, that is, it will have the oxidation number of -1, and that is why it will be -6. So what we will get? We will get by, so, and it will be 0 because this is a neutral compound. This, for the neutral compound, that would sum of the oxidation number of all the atoms in that compound, that will be 0, and for that it will be 0, and at that time we can find out this X equal to +2. That is, the oxidation number of the Fe is +2. So now another example we are giving Fe3O4. You have to find out the oxidation number of this Fe, because here you can see there is a 3 Fe atoms, and if you go for this type of problems will come in the IIT JEE, that each time at that time some examples, some will be there, calculate the average oxidation number. At that time, average oxidation number, that will be, you can easily able to calculate, that is 3x minus 8, which is equal to 0, and this will be x equal to 8 by 3, positive 8 by 3. But if they say what will be the actual oxidation number, this is the average, this is not actual. Actual oxidation, for that you have to know this Fe3O4 is basically the mixture, stoichiometric mixture of FeO and Fe2O3. This is the stoichiometric mixture. So Fe having the two oxidation number here. In this case for FeO, it will be that you can calculate, it will be plus 2, and here you can calculate, it will be plus 3. So this type of question may come. You have to answer this. That assign, that find out the oxidation number of this Fe of this compound. It is same or it is different. Then you have to know this, that it will be different and it will be this. Another example, suppose H2O7. This is the oleum. This is called the oleum. What will be the oxidation number of this sulfur? It is same or different. For that, you have to calculate the oxidation number on the basis of the chemical bonding of that particular atoms. Here you can see sulfur. If you see the structure, you will find this will be like this. This will be like this, and at that case the oxidation number of these two sulfur will be plus 6, same. But for this, this is sodium thiosulfate. What about the oxidation number of this sulfur? It is same or different? For that, in this case, you have to again go to the structure of this compound, that is a chemical bonding, how this sulfur atom is attached to each other. That in that case, you can see here, you have to go for the this is the structure of this compound, and you can see that is totally different. Here two sulfur atoms has been joined differently, and that is why its oxidation number will be different. Here you can see the sulfur is joined to the 3 electronegative element oxygen, so its oxidation number will be plus 6, whereas this terminal sulfur is joined to this central sulfur, is oxidation number will be minus 2. So this type of question sometimes come, and you have to give an option, different option, then you have to know this and you can able to answer it correctly. So for this sodium sulfide you will get this. Now for this compound, ammonium nitrate, here also you can see there is a 2 nitrogen atom. what will be the oxidation number? It will be same or different. For that, you have to see that it is an ionic compound and it is having this NH4 plus this. This is a cation and this is an anion. And on the basis of that, you have to calculate the oxidation number. How? Now this is X plus 4, because hydrogen having this always plus 1 oxidation number, and this will be, this is the charge. Charge is plus 1, that is a plus 1. So you can see this X will be minus 3. So its oxidation number will be minus 3. And here you can see X minus 6 is equal to minus 1, means X will be plus 5. So you can see it will be plus 5. So the same. So that is all for today's lecture. In this lecture we have discussed about the oxidation number, and we have understand all the rules regarding this oxidation number, and how do we able to calculate the oxidation number of different atoms in a compound, and how we able to calculate this oxidation number from the structures also. You have to take the assistance of the structure sometimes when there is a more numbers of the same element, same atoms will in the compound. Thank you very much for watching. Thank you.